Alright guys, welcome to the part 2 video for your review. These are going to cover the second page on your review, so that will be numbers 9 through 14. How long is this one? Yeah, 9 through 14. I'll do page 3 on a separate video. So, for numbers 9 through 14, we're going to start with number 9. Number 9, the quadratic function h of t is equal to negative 16t squared plus 8t plus 7 represents the height of feet of a jelly bean tossed in the air. When will the jelly bean hit the ground? So these word problems typically, especially in this unit, need calculators. So I'm going to take my calculator and I'm going to put down that equation. Hopefully I don't remember. Or I don't forget. Negative 16x squared. Now I know it said t squared, but make sure when you're putting any function into your calculator that you're putting it in with x's, not t's. So I'm going to have negative 16x squared plus 8 plus 8x. It says 8p, but make sure you're using x plus 7. Plus 7. So negative 16x squared plus 8x plus 7. And the point at which it hits the ground are going to be our x-intercepts. So remember, to find your x-intercept, you press menu on your calculator. And I know you may not have a calculator at home, so just watch these steps to do the review. And press menu, analyze graph, and intersection. So, not intersection, I'm so sorry. Menu, analyze graph. 0 is what we're looking for intercepts. So you should get this kind of dotted line. We're going to go a little bit left. Click the middle button in your calculator to choose it. Doesn't matter how left you go. The thing that matters is that you want the x-intercept to be inside the shaded region. Now, don't try to catch both x-intercepts. Notice it only show one at a time. So this is good enough. And I find my first x-intercept, which is about negative 0.457. And then we're going to do the same thing for our second x-intercept, analyze graph. 0, which is what we do for x-intercepts. And we're going to get the x-intercept within the shaded region. Doesn't matter how far right I go, just make sure that you are catching that x-intercept in that shaded region. So I can see that these are my two x-intercepts. So what I'm going to do here is I'm going to write down these two x-intercepts. So, let's write them here. My critical values are x equals negative 0.4571. You may hear my cats in the background. Hopefully they're not too distracting. And x equals 0.9571. So these are my two x-intercepts. And what I'm going to do, I'm going to say, okay, well, for these two x-intercepts, since I'm talking about the real world, and usually in these cases, x represents time, especially when we're talking about like height. You can't have negative time in the real world. You're not going to say, hey, at negative 0.4 seconds, this is height jump. So we can only use this. So this is our answer. So the jelly bean will hit the ground after this many seconds. I would write out the answer, but my writing will look even more messy using the technology I'm using right now. I'll try it. The jelly bean will hit the ground after, that's an A, 0.9571 seconds. Hopefully that's somewhat legible. You may see this kind of wording on your test. So suppose a student dove to catch the jelly bean 1 foot above the ground. So in the previous problem, we just had our equation. So for this one, since we want to be 1 foot above the ground, what we're going to do is we're going to take our equation, negative 16. I'm just going to change it to x since I'm going to graph x anyways. Negative 16x squared plus 8x plus 7, and I'm going to make it equal to that 1. And then I'm going to now make it equal to 0. Now that 1 came from here, that 1 foot. Subtract 1 from both sides. So my equation is actually negative 16x squared plus 8x plus 6 equals 0. And this is what I'm going to graph to find my new x-intercept. See how long it takes for it to get caught. So, let's try this. Let me pull my calculator up and press tab. Oh, right there. Tab and up. Tab and up will let me edit my previous equation I've already done. And all that changed is this became 6 now. So just enter here are my new x-intercepts. It kind of already kept my x-intercepts in mind. So I'm going to write those down. So my two critical values in this case were x equals negative 0.4114 or 11, I don't remember what was on there, something like this, and x equals 9114 or 0.9114. Now, same thing as the previous problem, you can't have negative time, so my only answer is this one, seconds. So that's how much time has elapsed. I'm not going to write it out this time. Essentially, you would write something along the lines of the jelly bean will be caught after 0.9114 seconds. Ta-da! First two is not bad, but they are calculator questions, so if you're doing it at home, you can use Desmos if you want to graph this equation. Desmos will let you do that, so you can use Desmos if you want to. Or just look at this video to kind of see how you would have done it with the calculator. Problems 11. So the table represents the function f of x is shown. Use the table to determine the real solutions of the equation f equals x, or f of x equals 0. If applicable, determine a reasonable interval in which the solution can be found. So we can see that I have a solution. And remember, solution is another word for x-intercept. I have an x-intercept here. And you would say, okay, that's my only x-intercept because that's the only time y is equal to 0. Now be careful here. This is a y-intercept. That is not a solution. Solutions are only x-intercepts. So remember, that's an x-intercept. So we found the first part of our answer, and the next part says, okay, determine a reasonable interval in which the solution can be found. So where are we going to have another x-intercept? Because parabolas usually have two x-intercepts, whether they're facing upwards or downwards. So we're going to see, okay. So I can see that, okay, I go from 23 to 0 to negative 11 to negative 10 to 3 to 28. Do you notice something? First off, notice how you go from 23, I'm decreasing, 0, negative 11 decreasing, negative 10 decreasing. But then here, we kind of have this interesting thing where I go from decreasing, negative 11, and then we start increasing, 3, 28, 65. When that happens, that's usually because you hit an interval, you hit another x-intercept. So we're going to say that our interval is between 0 and 1. That was my cat. So this is our interval. That's where we imagine our next intercept is going to come from. So somewhere between here. So for the next part of our problem, you could also do quadratic regression, I suppose, and get an equation, and then graph that equation to actually figure out what your x-intercept is, or just kind of think through it in this type of problem. So for numbers 12 to 13, a bird flies past from one plant to another. Can be represented by a quadratic function. Starting from the plant at ground level, the butterfly proceeds to reach a height y, 2 feet, when it was 1 foot away from its initial location horizontally. The butterfly landed on another plant at ground level, 2 horizontal feet away from where it started. So this first paragraph, this is going to be the one where our kind of just most recent lesson where you have a system of a linear equation and a quadratic equation. So first we have to determine this first paragraph, is it a linear system or a quadratic system? And in fact, if you check right here, it tells us, hey, quadratic function. So that means we're going to use quadratic regression. Now to use quadratic regression, we need 3 points. you only use 1 point or only use 2 points, your calculator is going to give you an error. Now our first set of points, I can see that I have 2 feet when it was 1 foot away from its location horizontally, so that's a point. So 2 feet when it was 1 foot away from its initial location horizontally. Now this means horizontally is your x value, so we're going to have the point 1, 2. And then the butterfly landed on another plant at ground level 2 horizontal feet away from where it started. So we're going to have another point 2, and so 2 horizontal feet away from where it started, so 2, 0. And then we see somewhere here, starting at ground level. So that means 0, 0. So we're going to use these points to kind of help us find our quadratic equation. So I'm going to go down here, and I'm going to go to a calculator page. I'm no longer on the graphing page. And this is your menu 616, quadratic regression. Simply do control N parentheses, and we're going to type in the x values. I already forgot what they were. So 1, 2, 0, 1, 2, 0, and then control N parentheses, and we're going to type in our y values. I already forgot what they were. 2, 0, 0. 2, 0, 0. I say okay, and here's our equation. -2 is our a value, 4 is our b value, and remember, anytime you have an e involved, that essentially means a 0, so there's actually no c value, so no c value. So if this is my a and this is my b, my equation, where's this? Will turn out to be, ignore the pelican as my background, will turn out to be y is equal to -2x squared plus 4x. And remember, since there was an e involved in one of my equations, I don't write the c value, so my b value was 0, so this is just it. So these are my 3 points. And if you have any questions on how to find those points, feel free to ask your teacher, but ta-da! That's mostly what you have to do. The hardest part is figuring out what your points are. And the hardest third point to find was probably to realize that when it tells you that it starts at a ground level, we have the point 0, 0. Now we have to do the same thing here. Now for the second one, it tells us that we have a linear function. So we're going to use linear regression. So for our points, we have a dragonfly. So a dragonfly, instead of a butterfly, begins its flight in the same plant but on a branch 2 feet above the ground. So we're starting 2 feet above the ground. So 0, 2, that's my starting point. It reached a height of 1 foot when it was 1 foot away from its initial location horizontally. The dragonfly's path can be represented by a linear function. So I can use linear regression. So let's do that. So almost similar method. Menu 6, 1, but this time I'm going to look for linear regression. And I'm going to type in my values. So let's go down. 0, 1 for my x's. Oops. And then what were my y's? 2, 1. And I end up with this equation. -1 is my x, and 2 is my b. Keeping in mind that when it's telling me, oh my bad, did I say x is my m? And b for mx plus b. These are and r squared values you don't really need, so we only want this portion here. So it's going to be -1 for my m, so -x, plus my b, which is 2. So, whoopsies, not again. What we're going to have is y is equal to negative x plus 2. These are my two equations. But we're not done. We're finding when their two paths will intersect. So now that I have my two equations, I can now graph said two equations. So, back to my calculator. I'm going to go to my graphing page. And the graphs actually should have saved. Ta-da! This is one of them. The negative 2. It's rounded, so that's why it says negative 1.999. But when you do regression, it does save your graphs. Tab. And then I go up. So function 2 was my quadratic graph, and function 3 is my linear graph, the negative 1x plus 2. You can also just retype them. So here are my graphs, and I can see that there's two intersection points. So I'm going to do menu, analyze graph, and now I want to use intersection. Now, doesn't matter how far left you are, just as long as your intersection's in the shaded region. Now you don't want to try to catch both intersections because sometimes they'll only show you one at a time. So let's just do the first one. So I can see they intersect here. And then we will do the second one. So menu, analyze graph, intersection. So here are my two intersections at 0.5 and at 2. So let me write down those points. They intersect at 0.5, 1.5, and 2, 0. And then you would say, you kind of see in the answer that it says, hey, they intersect. This is height, by the way, and this is horizontal distance. So you would write this in some paragraph form. You can look at the answer if you want to see how to write it. I'm not writing it. It's really long. Essentially, it just says the insect's path will intersect at a height of 1.5 feet and a horizontal distance of 0.5 feet from their initial positions. So 1.5 feet and 0.5 feet horizontally from the initial. They will intersect a second time on the ground at a horizontal distance of 2 feet from their initial position. So make sure, the reason you want to know how to write it down, so I would practice writing it down, because when you see it on your test, it'll be a multiple choice answer. So you want to make sure you're able to pick the correct sentence. So problem 14 is the last one for this video, and let's see, describe the possible number of solutions that may occur when solving a system of equations consisting of one linear equation and one quadratic equation. Sketch the graph to justify your solutions. So we have three cases actually. Where am I going to write it? We have the case of, I'm going to do that, two solutions. Let me write it down first. We have the case of one solution, and I'll draw them in a second. And then we have the case of no solutions. So let's go out here. So what this may look like for two solutions, you may get a graph that looks like something like this. And then your linear graph could go here. And so your two solutions would end up being here and here. So you may get, might look like this, might look slightly like this. But the idea is that your linear graph will cross your parabola twice. Now for one solution, what might end up happening is that you get a parabola that's kind of like this, and it actually only touches maybe here only. So that would be a case of one solution. And then no solution, kind of like what it sounds like. You might get a parabola like this, and then a linear graph down here. And no matter how far off you'll go, they'll actually never intersect. So you would have no solution. So for your solutions, it depends on your intersection. So two solutions means two intersections. One solution means one intersection. No solution means no intersections. So draw something along this line for problem 14. That's it for this video. For the next video, I'll do the rest of page 3 of your review. But hopefully it's helped. If you have questions, feel free to ask your teacher.